All right, imagine this. You're a heart surgeon,
Mm-hmm.
but instead of scalpels and sutures, you're controlling a robot
Okay.
with microscopic precision.
Yeah.
This is the future of surgery, right?
Absolutely.
And to get there, robots need to be masters of obstacle avoidance.
Mm.
That's where NVIDIA comes in.
Right.
They're not building the robots themselves.
Yeah.
They're focused on the brains, the AI that makes these machines move with incredible grace.
Right.
We've got a stack of research on how NVIDIA is revolutionizing obstacle avoidance.
Okay.
And today, we're going to dive deep into the tech,
Sounds good.
the impact, and why it's such a huge leap forward.
I think to really appreciate how far we've come,
Yeah?
it's helpful to understand the old way of doing things.
Okay.
Older robots basically just measured the height of objects,
Oh, okay.
almost like those early Roombas,
Oh, right.
bouncing off walls. Not exactly elegant, right?
Oh, yeah. I read about one that got tangled in cables overnight and dragged desks across the lab.
Oh, gosh.
Can you imagine walking into that mess?
I can't.
Talk about a robotic rampage.
Yeah, it definitely shows why we need a smarter approach.
Yeah.
NVIDIA's tech uses AI and advanced sensors.
Okay.
So robots can understand context,
Right.
not just shapes.
Yeah.
Think of it like this.
Okay.
The robot doesn't just see a cable.
Right.
It understands what a cable is and that it shouldn't drive over it.
So it's like going from basic sight
Yeah?
to actual understanding.
Right.
But how does that actually work?
Sure.
Break it down for us.
Okay.
What's the magic formula?
It starts with perception.
Okay.
The robot uses sensors like
Yeah.
cameras,
Yeah.
LiDAR, and depth sensors
Okay.
to gather data about its surroundings.
So it's like giving the robots
Right.
its own senses
Mm-hmm.
to perceive the world.
Right.
Okay. So the robot is taking in all this raw information.
Yeah.
What happens next?
That's what data processing comes in.
Okay.
The raw data gets cleaned up and filtered
Right.
to remove any errors,
Got it.
ensuring the robot has an accurate picture of what's around it.
So it's all about making sure the data is top-notch
Yes.
before moving on.
Right.
What's the next step in this robotic recipe?
This is where things get really interesting.
Okay.
Object detection and classification.
Okay.
The robot uses powerful deep learning models to identify and categorize objects.
So is it a cable, a cart, a ladder?
Right. Each object gets a label,
Okay.
helping the robot understand its properties.
Well, so for example,
Right.
is it something that moves,
Yeah,
something fixed,
Uh-huh.
or something potentially dangerous?
exactly.
Wow. So it's not just seeing a jumble of stuff.
Right.
It's recognizing specific objects.
Yep.
And understanding their characteristics.
Yeah.
It's like the robot is learning the language
Mhm.
of its environment.
Exactly. And this level of understanding is
Yeah.
key for effective obstacle avoidance.
Mm-hmm.
But it doesn't stop there.
Okay.
The robot then uses something called semantic segmentation.
Hold on.
Yeah.
Semantic segmentation.
Yeah.
That sounds pretty intense.
It is.
What exactly does that involve?
Imagine the robot is painting its surroundings.
Okay.
Every pixel in its view gets labeled
Okay.
as either passable
Right.
or impassable.
Okay.
So it's not just recognizing objects,
Uh-huh.
it's understanding the whole layout of its world
Okay.
and knowing where it can and cannot go.
Wait, so it's literally building
Yeah.
a digital twin of its surroundings.
Yeah.
Like if I put on some VR goggles,
Mm-hmm.
could I see the robot's internal map
You got it.
and walk through it virtually?
Yes. Having this detailed map is crucial
Okay.
for the next step, path planning.
So the robot has gathered data,
Right.
categorized everything,
Mhm.
and built its map.
Yep.
Now it's ready to chart a course
Yes.
and actually navigate.
Using sophisticated algorithms,
Okay.
the robot figures out the best path to
Okay.
its destination, making sure to avoid all the obstacle it's identified.
Right.
It has to consider both a global path
Okay.
for the overall route
Yeah.
and make real-time adjustments
Got it.
to avoid moving objects.
Yeah.
Like if someone suddenly walks into its path.
It's like having a super smart GPS,
Yeah.
but for a robot,
Mm-hmm.
navigating a constantly changing environment,
Right.
no more awkward collisions.
Nope.
But I have to ask,
Sure.
how do they train these robots
Yeah.
to do all this?
No.
Do they just let them loose in the real world
No.
and hope for the best?
Definitely not.
I can only imagine the chaos.
That would be a recipe for disaster.
Right.
Instead, they use
video.
NVIDIA's Isaac Sim,
Isaac
a powerful simulation platform.
Okay.
Imagine a hyper-realistic video game
Right.
designed for training robots.
Okay.
Developers can create virtual environments,
Yeah.
like factories, warehouses, or even city streets, complete with obstacles.
So the robot gets to practice. It's ninja obstacle avoidance skills
Exactly.
in a safe virtual world.
Yeah.
No real-world crashes.
Nope.
Or confused humans.
No.
It's pretty clever.
It is. And not only is it safer,
Yeah.
but it's also super efficient.
Right.
They can run countless simulations in a short amount of time,
Okay.
testing out different scenarios
Yeah.
and algorithms to see what works best.
It's like giving the robot years of experience in just a few hours.
Exactly.
That's mind-blowing.
It is pretty amazing.
But can these robots handle something they've never encountered before? What happens when they encounter something totally new?
Well, that's where things get even more futuristic.
Okay.
NVIDIA is working on something called zero-shot detection.
Zero-shot detection.
Ready for this?
Yeah.
Robots can now identify and locate objects they've never seen before.
Hold on.
Yeah.
Are you telling me these robots can basically learn on the fly? How is that even possible?
It leverages the power of deep learning and large language models.
Right.
The robot has already been trained on a massive amount of data, giving it a vast understanding of the world.
So even if it comes across a brand new object,
Exactly.
it can use its existing knowledge to figure out what it is and where it might be.
Right.
This is opening up a whole new world of possibilities.
Absolutely.
Robots that can adapt and handle the unexpected.
It is a huge leap forward.
It's like they're becoming truly intelligent.
It seems that way.
But there are still some challenges ahead.
Of course.
One of the biggest hurdles is the need for more real-world data.
Yes. We have tons of data from humans interacting with the world, but we're only starting to gather that kind of data for robots.
So it's like the more experience robots get in the real world, the better they'll become at navigating it.
It makes sense.
Yeah, it makes sense.
Simulation is a great starting point, but real-world experience is key to unlocking the full potential of these robots. But that brings up another interesting challenge. Making sure the robot's knowledge from the virtual world translates smoothly to the messy, unpredictable real world.
Yeah.
It's not always a seamless transition.
That makes sense. It's like learning to drive in a video game versus actually getting behind the wheel for the first time.
Exactly.
There's a learning curve for sure.
Absolutely. That's a great analogy.
Yeah.
And that's actually a perfect segue into the next part of our deep dive.
Okay.
We'll explore the challenges of sim to real transfer, the potential pitfalls, and how researchers are trying to bridge that gap between virtual mastery and real-world performance.
Sounds good. Okay. So we've trained our robot in a perfect virtual world. It's aced all its obstacle courses. It's basically a digital ninja.
Right.
But then we release it into the real world and splat faceplant into a trash can.
Oh, no.
Why is that jump from simulation to reality such a tricky hurdle?
Well, think about it.
Okay.
In simulation, everything is pristine, predictable, perfectly lit.
Right.
The real world.
Yeah.
It's messy.
It is.
Unpredictable and full of surprises.
Yeah, for sure.
Lighting changes, objects move unexpectedly.
Right.
There are weird textures and reflections.
Okay.
Things that might not have been factored into the simulation.
It's like the difference between practicing your golf swing on a simulator versus stepping onto a real course.
Right.
Suddenly there's wind, uneven terrain, and you realize that little white ball is a lot harder to hit than it looked on the screen.
Exactly. And it's not just about visual differences.
Okay.
In the real world, there's physics to contend with. Right.
Friction gravity.
Yeah.
The unpredictable way objects behave. A robot might have mastered grasping a virtual object.
Okay.
But in reality, a slight miscalculation in force or angle can send that object flying.
So how do researchers tackle this sim-to-real challenge? How do they make sure a robot's virtual skills translate to real-world success?
Well, one approach is to make the simulation itself more challenging and varied.
Okay.
Instead of training the robot in a single,
idealized
virtual environment, they use something called domain randomization.
Domain randomization.
Imagine creating dozens of virtual worlds.
Okay.
Each with slightly different lighting conditions.
Okay.
Object placements.
Yeah.
Even textures and colors.
So the robot isn't just learning to navigate one specific virtual world. It's learning to adapt.
Exactly.
To a range of possibilities.
Yeah.
Making it more robust.
And ready to handle the real world's curveballs.
Exactly. It's like training for a marathon in all kinds of weather.
Okay.
Heat, rain, wind.
Right.
So you're prepared for anything on race day.
Yeah, that makes sense.
Another promising technique is sim-to-real transfer learning.
Sim-to-real transfer learning.
The robot learns the basics in simulation and then fine-tunes its skills in the real world using real-world data to adjust and improve.
So it's a combination of virtual boot camp and real-world experience.
Exactly.
What kind of real-world training do these robots get? Do they have tiny robot mentors showing them the ropes?
That would be cute. But one method involves using human demonstrations. A human expert can guide the robot, showing it how to perform a task correctly. Providing feedback and making corrections in real time.
So like a master craftsman.
Exactly.
Passing on their skills to an apprentice.
Absolutely. Even a small number of demonstrations can significantly improve the robot's performance. Plus, it brings a human element into the training process, which can help ensure the robot is learning to perform tasks in a way that aligns with human expectations and safety standards.
That's a really interesting point.
Yeah.
It's not just about teaching robots to do things. It's about teaching them to do things in a way that's safe, efficient, and in line with how we do things in the real world.
Exactly.
But let's be honest.
Sure.
There are probably still times when a robot, even with all this training, encounters a situation. It just doesn't know how to handle what happens then.
So
does it just freeze up like a deer in headlights?
Well, ideally, you want the robot to be able to recognize when it's out of its depth and call for help.
So it's like the robot raising its hand and saying, hey, I need some assistance here. This is outside my comfort zone.
Right. Researchers are working on ways to give robots a sense of uncertainty, allowing them to flag situations where they're not confident in their ability to proceed safely.
So it's like the robot knowing when to call for a consult. Or a second opinion.
Right.
It's about knowing your limits.
Exactly.
And prioritizing safety above all else.
Yeah.
But speaking of different environments, we've talked a lot about industrial applications for robots, factories, warehouses, and so on. But what about robots for everyday life? Robots that can help us around the house? Or provide companionship? What's happening in that space? It seems like robots are poised to take over factories and warehouses. But what about our homes? Are we going to have robot butlers and maids anytime soon?
Well, maybe not butlers and maids just yet. But we're definitely seeing a surge.
In robots designed for everyday life.
Like what kinds of things?
So companies like iRobot, the folks behind the Roomba vacuum, are branching out. They're making robots that can mop, mow lawns. And even clean gutters.
So instead of doing chores, we can just supervise our little robotic cleaning crew. That sounds pretty appealing.
It does.
But what about robots that can actually interact with us? Like companions or helpers.
There's a lot happening in that area, too.
Oh, cool.
Companies like Embody, specifically designed for social interaction and emotional support.
Really?
Imagine a robot that can chat with you.
Wow.
Play games. Or even provide comfort if you're feeling down.
That's incredible.
It is.
It's like having a friend. Who never gets tired of listening to you.
Exactly.
Or playing another round of Scrabble.
Yeah, but honestly, it's a little mind-blowing.
I know.
To think how far robots have come. We've gone from clunky machines, bumping into walls, to robots that can perform surgery, explore disaster zones, and even offer companionship.
It's pretty remarkable.
It makes you wonder what's next. What are the frontiers of robotics that researchers are most excited about?
Well, one area that's generating a lot of buzz is swarm robotics.
Swarm robotics.
Imagine dozens or even hundreds of tiny robots working together like a colony of ants, coordinating their actions to achieve complex goals.
That sounds like something straight out of a sci-fi movie.
It does.
What kind of tasks could these robot swarms handle?
They could be incredibly useful for things like search and rescue operations, environmental monitoring, or even building structures in hazardous environments.
So think of it like having a highly adaptable and resilient team of tiny robots that can cover a lot of ground and tackle tasks that would be difficult or dangerous for humans.
Exactly.
It's amazing to think how these advancements could be used to solve real-world problems and make our lives easier and safer.
Absolutely.
But as with any powerful technology, there's always a flip side. What are some of the potential downsides or challenges we need to be mindful of as robots become more integrated into our lives?
One of the biggest challenges, and something we touched on earlier, is ensuring that robots operate safely and reliably in the real world. We need to develop robust safety protocols, fail-safe mechanisms, and ways to predict and prevent potential accidents.
The last thing we want is robots running amok. Causing harm or wreaking havoc.
Exactly. A robotic uprising is not exactly the future I'm hoping for.
So it sounds like we've got a lot to figure out.
Yeah.
Both on the technical side and on the ethical side.
Absolutely. As robots become more intelligent, autonomous, and integrated into our lives, we need to have thoughtful conversations about their role in society, the ethical implications, and how we can ensure they're used responsibly and for the benefit of humanity.
It's not just about building cool robots. It's about shaping a future where humans and robots can coexist and collaborate in a way that's beneficial for everyone.
Exactly.
Well, this deep dive has been an incredible journey. We've explored the cutting-edge world of obstacle avoidance, the challenges of bringing virtual robots to life, and the exciting possibilities of robots in our homes. And in the wider world.
It's been a fascinating exploration.
It has.
And it just goes to show that the world of robotics is constantly evolving, pushing the boundaries of what's possible. Who knows what incredible advancements we'll see in the years to come.
One thing's for sure.
What's that?
The future is going to be anything but boring.
I completely agree.
Thanks for joining us on this deep dive.
It's been a pleasure.
And we'll see you next time.
Okay.
For another adventure into the world of cutting-edge tech.